Hey there, John. All right, so praying your week is going well. As you know, I'm kind of up a little late trying to put a couple of these videos together. I haven't had a lot of prep time, but just kind of looking at your homework and looking at what you might need to know for this week. It looks like based on the schedule, I think I printed it out for you. If not, let me know and I can send it to Mom so that she has it. Monday is section 4.4. Wednesday is just a review of the unit circle and then practicing sections 4.1 through 4.4. So this is a short class because there's a service project. So there's, excuse me, not a lot there. And then Thursday is the quiz, and then Mrs. Carricker is going over graphs of sine and cosine functions. So that's section 4.5. So I'm going to make a video for 4.4, let you do your own review from sections 4.1 through 4.4. Really, you need to focus on section 4.2 and 4.3. Maybe some of 4.1, not really 4.4 for the quiz. Okay. So let's do section 4.4. So we've got, and this is basically like trig functions of any angle. Okay. So again, remember that we've got 6 trig functions. Right? So if I've got any triangle now, this is the opposite, which most of the time is y, the adjacent, which most of the time is x, and then the hypotenuse. Again, these are related by x squared plus y squared equals hypotenuse squared. And so then sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And then everything else is built out of sine and cosine. So tangent is sine over cosine. And then the opposites of these, remember the opposite of sine is cosecant, not secant. That's 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. Okay. So for example, if I were to give you an angle where this coordinate right here was, let's just say it's 5, 5. And I were to say, okay, what's the sine of this angle right here? What's the cosine? What's the tangent? What's the cotangent, etc.? So again, you would be able to get this by getting this third side. So in this case, it would be 5 squared plus 5 squared square root. That's square root of 50, okay, which is 5 root 2. And then you would start taking to get the sine. Remember, sine is opposite over hypotenuse. That would be 5 over root 50. In other words, 5 over 5 root 2. I just pulled a 25 out, and when you pull that out of the square root, it becomes 5. And 5's cancel, I get 1 over root 2, which is root 2 over 2. And that should look familiar because this is actually a 45, 45, 90 triangle. So we're getting the same values that we normally would. Same for cosine. Cosine is adjacent over hypotenuse. And again, that's going to be root 2 over 2. Okay, and you can get tangent opposite over adjacent, or just take sine over cosine. Tangent's going to be 1. Flip these to get cosecant and secant, etc. Okay? So hopefully that, if you need me to send you another example, let me know. You can have Mom text me, or you can text me on Mom's phone. If you need me to need me to send another example of one of these, that's totally fine. Couple things to notice. Remember, we've got 4 quadrants here. This is first, second quadrant, third quadrant, and fourth quadrant. Notice they're labeled by capital Roman numerals. That's very normal. For angles in here, everything is positive, right? These sides are all positive. So the sine is going to be positive and the cosine is going to be positive, and therefore all of this stuff is going to be positive. Once we start getting into some of these other quadrants, like here, excuse me, the sine is positive, but the cosine is negative, right? Because the x part is, cosine's x and sine is y. Sine is, y is going this way, but x is going this way. X is negative. So cosine's going to be negative, but sine's going to be positive. Down here, the x and the y are both negative. So sine is negative, cosine is negative. So you're, but notice, for instance, if I take a negative over a negative, tangent's going to be positive. So not all of the trig functions are going to be negative down here. You have to be careful. You have to think through what's going on there. And here the y is negative, sine is going to be negative, but the x is positive, so the cosine is going to be positive. So you'll have a couple of examples of problems, I think, from section 4.4, like 23, 25, that are talking about if you're in a particular quadrant, which functions are positive, which ones are negative. We're kind of checking on those, okay? As we start to get into, let's take an example like number 28 now from section 4.4. So what this one says I've got an angle whose cosine is negative 4/5. And that angle is in quadrant 3. Okay, so what I'm going to do is just draw an angle in quadrant 3. Okay, so there's an angle in quadrant 3. And the cosine is negative 4/5. Now we know that if it's negative 4/5, the negative part is the x part, so this is negative 4. And then, so it's adjacent cosine. Remember, cosine is adjacent over hypotenuse, ca. Negative 4/5. So adjacent over hypotenuse, negative 4/5. And so I need to figure out what is this third side. So I know that if I call that, let's call it y. Y squared plus negative 4 squared is 16 equals 25. So y squared is 9, and y is plus or minus 3. Which one is it? In this case, it's negative 3, right? Because the y part's negative. So now if it's asking for find the other trig functions here, if I want the sine of that angle is negative 3/5. You see that? Here's my angle. Opposite over hypotenuse. The cosine is negative 4/5. The tangent is going to be negative 3/5 over negative 4/5. So the negatives cancel and the fifths cancel, and I get 3/4. That's my tangent. Okay, cosecant is going to be the flipped version of sine. Secant's going to be the flipped version of cosine. And cotangent's going to be the flipped version of tangent. Okay, so your problems like number 27, 29, 31, those are going to be like this. Now 31, I noticed that it talks about secant. They give you that the secant of an angle is negative 2. Remember, if you know the secant, then you can use that to figure out the cosine. Cosine's always the flip. So if secant theta is negative 2, then the cosine of theta is what? Start with that. And then draw a triangle and work your way from there, okay? Good. Now, most of these problems, like number 39, number 41, number 43, number 45, you got to draw the angle, like draw the angle pi, and then figure out, okay, what's the cosine, what's the sine, and then use that to get, or draw 3 pi over 2, or draw the angle 0. You know, make sure that you're drawing these angles, because that'll help you using the unit circle and figuring out with x and y, with cosine and sine, then that'll help you to determine the rest of these angles. Numbers 51 and 55 talk about using a reference angle, okay? And the idea here is that, let me erase some of this. Let's just take an example of like 7 pi over 6, all right? So 7 pi over 6 is just over pi, so it's going to be like this, okay? And so it's pi plus another 1/6 pi, so this is going to be pi, and then this is pi over 6. So if I'm thinking of drawing a triangle to get, like if somebody asked me what's the sine, I would draw a unit circle and then draw this in with pi plus another 1/6 pi. And then if somebody asked me what the sine is, I would have to remember, okay, this pi over 6, that's like 30 degrees, so I've got a 30, 60, 90 right triangle here. One side is 1/2 and the other side is root 3 over 2. Which one's which? The shorter one is opposite the smaller angle. So this is 1/2. This is root 3 over 2. But we're negative in both situations because we're going this way and this way. And so if somebody were to ask me what's the sine of 7 pi over 6, that's the y part here, y over 1, so that's negative 1/2. The cosine of 7 pi over 6 is the x part, which is negative root 3 over 2. Okay. When they talk about reference angles, this is the original angle, but I'm not really ever using 7 pi over 6 when I'm doing these calculations. I'm drawing it and then using this angle that's somewhere between 0 and 90 degrees to actually calculate the triangle. So in this case, my reference angle for 7 pi over 6 is just pi over 6. It's the angle that I need when I'm drawing the triangle and trying to figure this out. Okay? Let me give you another, I'll give you another example. If my angle is negative pi over 3, okay, normally we go this way counterclockwise, but for the negative we're going to go the other direction. So negative pi over 3 is going to look like this. Okay, so it's going to be 60 degrees that way. So now if I were to actually do a calculation, I don't use negative angles here, right? So I would be thinking, okay, this angle right here is pi over 3, which is 60 degrees, and then that means this is root 3 over 2, this is 1/2, but that's negative because it goes down. Right, and that's what I would use to calculate my sine and cosine and stuff. That angle right there, pi over 3, is my reference angle. So they're labeling the reference angle theta prime, but all they mean by theta prime is just it's the angle that we use to actually do the trig calculations. Normally we don't use negative pi over 3 or some huge angle like 7 pi over 6. We just use some smaller angle between 0 and 90 degrees to do that calculation. So hopefully that makes sense. If you've got questions, let me know. But numbers 47, 51, and 55 are all based on that. So it's just drawing. You don't have to do any trig calculations on those 3 problems. You just have to draw the actual angle they give you, and then figure out, based on what the triangle looks like, what's the real angle between 0 and 90 degrees that you would use that's connected to that angle. Okay. For 67, 73, and 77, they want you to actually draw the angle, use a reference, drop a perpendicular, use like we did here. So draw the angle, drop a perpendicular to the x-axis, and then we're going to use that reference angle to actually calculate what is the sine, what's the cosine. It looks like they just want 3, sine, cosine, and tangent for 67, 73, and 77. So for instance, if I did 68, sorry, I'm not doing 67, but if I did 68, so 68 gives me 300 degrees, and I'm supposed to find the sine, cosine, and tangent. So 300 degrees is almost 360. So it's around, but I'm still off by 60 degrees because 360 is all the way around, right? So this right here is 60 degrees. And this is my triangle right here. Now 60, in using the same idea that we were talking about before, 60 degrees would be my reference angle. So my theta prime, the angle that I'm actually using to do these calculations, would be 60 degrees. Okay. Since this is a 30, 60, 90 right triangle, one of these sides is 1/2, that's this one. One of these sides is root 3 over 2, that's this one, but it's going to be negative because y is negative there. And so if I were to find the sine of 300 degrees, okay, that's negative root 3 over 2, that's the y. The cosine is the x, that's 1/2. And then the tangent is sine over cosine. So negative root 3 over 2 over 1/2, and the halves cancel. So that's negative root 3. So that would be my answer for number 68. Okay? All right. There's quite a few of these. Sorry, you're having to practice this a lot, but it's good practice for you. Okay, number 79 and kind of 85. 91, 97, and 99 are just plugging stuff in your calculator. Just make sure on 91, 97, and 99 that you have your calculator in radians or in degrees, okay? Appropriate. Make sure you're watching out for that. For 79 and 85, let me take an example like one of those, okay? So let's do 80. Okay, yeah, let's do 80. Okay, so for number 80, what they say is that we're supposed to find the indicated trig value in the specified quadrant. Okay, so we have an angle whose cotangent is -3. We're supposed to be in the second quadrant, and I'm supposed to find the sine. Okay? So we've got an angle, so this is, again, number 80. I've got cotangent of theta is -3. I'm in the second quadrant, and I want the sine. So I'm going to go in the second, remember the second quadrant's right here. So I'm going to draw an angle over here. Okay, and drop a perpendicular. Technically the angle is this, but this is the reference angle right here. Okay, now let's start with, I'm going to want the sine, so I'm going to want this height right here, but I have to work with what I'm given. I'm given that the cotangent of theta is -3, and I don't feel comfortable with the cotangent. So I've got to start by converting that, finding, if I know the cotangent, then I know the tangent. So if the cotangent is -3, what's the tangent? Okay, if the cotangent's -3, tangent is 1 over that, so tangent's going to be -1/3. So if I flip it, right? Negative 3 over 1. Flipping that is negative 1/3. So tangent is negative 1/3, and that's opposite over adjacent. Okay? So this over this is going to be negative 1/3. Now notice the x part's negative and the y part's positive. So I'm going to stick the negative down here. But the opposite is 1 and the adjacent is 3. Notice I didn't draw my triangle very good to scale, but that's fine. Right? If I did this, if I took opposite over adjacent, 1 over negative 3 would give me that answer. The negative is here because of the x part. And since it's a fraction, opposite over adjacent, the opposite sign is going to be the top part and the adjacent side is going to be the negative part. Okay? And now I'm going to use my Pythagorean theorem to figure out what this side should be right here. Okay, so that side should be 1 squared is 1, plus 3 squared is 9, square root. In other words, that hypotenuse right there is root 10. Do you see that? And so now, once I know that, the sine is opposite over hypotenuse, and that is opposite over hypotenuse, 1 over root 10, or in other words, root 10 over 10. That would be my answer. Okay? All right. Now it's important that I was in the second quadrant because we used the fact that it was a second quadrant to tell me, okay, the cosine part was negative, the sine part was positive. Right? So that's the problems like 79 and 85 are going to be like that one. Finally, problems like 103, 105 are going to be, let's do an example like 103 or 105. Let's do 104. Okay. All right, what this is saying is that suppose I've got a situation where, so let's just do part A, the cosine of an angle is root 2 over 2. Now you should know some angles whose cosine is root 2 over 2, and we'll get to that in a second. The question is, can we find multiple angles that could fit in here? So first of all, this should remind you of the angle in the first quadrant. What angle has cosine root 2 over 2? This is one that you should know. This is 45 degrees, right? 45 degrees or pi over 4. So in that case, the cosine, remember the cosine's the x part, is root 2 over 2, and the sine is also root 2 over 2. So one angle that would work here is 45 degrees or pi over 4. But I'm supposed to come up with 2 solutions. Okay? So notice there's another angle. I mean, one way that you can do this is kind of dumb, but you could add 2 pi, and that would give you another angle whose cosine is pi root 2 over 2, but they don't want you to do that. They said you have to have an angle between 0 and 2 pi. So the other thing that I could do is I noticed that if I want the cosine to be root 2 over 2, the other way that I could do that would be to have a triangle down here. And in that case, my angle is this angle that I'm drawing in blue here. In other words, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. Or 360 degrees minus 45 degrees. So that's 315 degrees. Okay, the cosine is root 2 over 2, both for 45 degree angle and for a negative 45 degree angle. Negative 45 degrees is the same thing as 315 degrees. Okay? If instead I did part B, Part B has, I want an angle whose cosine is negative root 2 over 2. Well, the two places where cosine, remember cosine is x, the two places where cosine is negative is over here. So both of these, kind of 45 degrees here and 45 degrees here, would give me a cosine, an x part of negative root 2 over 2. So the first one, this angle right here, is 90 plus 45. That's 135, or 3 pi over 4, 3/4 of the way around. The other one is 180 degrees plus another 45, so 225, or 5 pi over 4. Okay, so that's two angles whose cosine is negative root 2 over 2. Okay? So I think that should get you all set for section 4.4, and then I'll prep a video for section 4.5. Praying for you, bud. Keep persevering. If you get stuck, you get frustrated, please send questions. This is not always easy. It takes a lot of practice. It might look easy, and that's because I've had a lot of practice, but it just takes some practice digging in there, working through it, working lots of examples, which is why you've got a lot of examples on the homework. And working through those examples helps it feel better and better and better. So make sure that you're getting that practice in. Love you, bud, and have a great beginning of your week.